Hello. Today we're going to learn about the lab experiment that deals with the Newton's law of experiment. Our title code of the experiment is C11. Okay. So the Newton's law actually deals with the cooling, whereby this cooling, you cool water from a certain temperature all the way up to where the temperature will be constant. All the way to introduction part, we shall see that what does the Newton's law of cooling states? The Newton's law of cooling says that the rate at which an object cools is proportional to the difference in temperature between the object and the object surroundings. This means that if we cool, let's say, a liquid, that's a water, you cool, let's say, from a temperature of 60 degrees all the way, let's say, to a room temperature, where by this room temperature will be, let's say, 24 degrees Celsius. So you have to cool that liquid from 60 degrees to 40 to 24 degrees, whereby you will see that when the temperature of the water reaches about 24 degrees, it will be at a constant rate. You see? So an example of this law of cooling is whereby when you see, let's say, a child boring, let's say, tea, it will cool from hot all the way to cool to that room temperature. Yeah. So to set up this experiment, there are some things that will be needed. Now will you set this experiment? First, instead like this one. Yeah. So you will have your beaker. Inside the beaker, you must have hot water. In that hot water, we'll insert a thermometer. This thermometer actually to measure the temperature. Let's say your liquid or hot water ranges from 60 degrees all the way. You want to cool up to, let's say, that 5 degrees. You will insert there, then you should calibrate the reading. Also, you will clamp the thermometer so that it will enable it to be firm. And you also clamp a beaker to make it firm also. Okay. Okay. So what's the purpose of this experiment? The purpose of this experiment is to investigate how objects cools. You will discover that the difference between the temperature of a cooling object and the room temperature can be modeled by an exponential function. Actually, you'll find that when you cool the hot water, you'll find that it will cool at a high rate at first. Then at the end, the temperature tend to be constant because of that, to adapt with that of the room temperature. So you'll find when you plot a graph, you will see that it will be an exponential curve. Okay, the objective of this experiment, actually, the experiment of Newton's law of cooling, we are much interested to investigate the Newton's law of cooling, and again, we are much interested to determine the cooling rate, the cooling constant. Actually, we want to see that what is the gradient of this water. What is the cooling rate of this hot water? Is it going to be directly proportional, or it will be inversely proportional? So we are much interested. Later, we want also to develop the data that analyzes and graph skills. We shall be graphing our graphs. We shall be plotting our graphs using Python program. We are much interested here to have that Python skills. Okay. We are finding that the major apparatus to use in this experiment, we are much concerned also, because as a student, you must know what's necessary, or what are the things that are necessary to have to do this experiment. So the major things that you must have, one is the thermometer. Why is that you need the thermometer? The thermometer will enable you to make a readings. You will use the thermometer actually to record the temperature. Also, you need to have a beaker. This beaker will enable you to hold that hot liquid. The necessary thing also is the stopwatch. This stopwatch will enable you to recording the time event. If the temperature cools at let's say every minute. So this stopwatch will enable you to view if the time has elapsed or not. So it will help you a lot. Heater, we use heater to heat that hot water. Those are the major things that you will need to have when doing this experiment. Okay, we are now going to see the theory part, the experiment. The theory part of this experiment, we have seen that according to the Newton's law of cooling, what it says that the rate of heat transfer, that's Q over T, that's find the heat rate transfer from its body, that's its surrounding, is proportional to the temperature difference between that body and its surrounding. You see, so we are much concerned to do what the Newton's law states. Now, do you calculate this experiment? We say that according to the Newton's law of cooling, we have find that it says that the cooling rate changing heat transfer is directly proportional to the heat transfer to the temperature difference. I mean, so it say heat transfer is directly proportional to the temperature difference by implementing this to be directly proportional. Mathematically, this relation can be expressed as the rate of heat transfer is equal to, you will negate with a constant and you multiply by the temperature difference. You see, we know that Q over T is the rate of heat transfer per unit time. This K, this letter K, it's a constant. You will multiply by a constant so that we have this coefficient of the cooling rate, which represents the object of its surrounding. Again, we will multiply by temperature difference of the object and its surrounding. To get the temperature difference, we will say excessive temperature minus the room temperature will get the temperature difference. Hope it's much understood. To set up the experiment, we need some guidelines about the procedure now to do the experiment. The procedures to do this experiment of Newton's law of cooling. First, we will have to heat the liquid. That liquid, let's say it's water. We will have to heat that temperature, that liquid up to the temperature of 60 degrees Celsius. And thereafter, we will draw that source of heat from the liquid so that it will enable you to cool. And again, after heating, you will sustain a thermometer inside the hot water. And why is it necessary to insert the thermometer inside that water? It will enable you to calibrate the reading, or it will enable you to measure the temperature of that liquid. After you have dipped, or after you have suspended your thermometer inside that liquid, you will have to stir that water. You will stir it continuously. You will stir it continuously to make it uniform distribution temperature. Number four is that after you have stirred it uniformly, you know that that temperature inside that water will be uniformly distributed. Thereafter, record the temperature reading every minute. When the 1 minute elapses, you look at the thermometer, record the temperature reading. Thereafter, continue the time temperature observation till the temperature becomes constant. After you have recorded your time and temperature, you will have to plot the graph. You will have to plot a graph between the temperature, that's the excessive temperature. And remember that to find the excessive temperature, you say is the temperature of that water minus the room temperature. You find the excessive temperature against the time. And when you plot this graph, you will identify, you see that the graph will be exponentially. Yeah, the graph will be exponential curve. It shows that if the temperature actually drops quickly at the beginning, then when the temperature tends to be much the same with that of room temperature, the curve will be much constant. So the graph will look like this. So your temperature, your temperature curve or the cooling, Newton's law of cooling will look like this curve. The excessive temperature against the time, it would be an exponential curve like this. When you plot a graph of excessive temperature against time. So this is the experiment that I was doing. Actually, you find that my temperature of the hot water was like 60 degrees Celsius. This is my middegree. And inside this water, the beakers hold this water. And you see at upper left hand, you'll find that there is my stopwatch here, whereby this stopwatch is measured in hours, minutes, and seconds. So this I will be observing my time and also the temperature. So if I play this video, you shall be recording, you will find that the temperature is dropping at a high rate. So you will record yours and you try or you observe yours. So you are seeing that 14 seconds the temperature is 58.4 degrees. So let's proceed on how you record your data. How will you tabulize your data? So when you record your data, you will record the temperature reading here. When the temperature, after every 1 minute, you record your temperature. This is the time. So you label 1 minute, 2 minutes, 3, 4, all the way until the temperature reaches constant. Yeah. So you start at 60 degrees. Look at it. After every 1 minute, all the way until the temperature remains. You have recorded your data or your readings. What will you supposed to do? You will go ahead and analyze your data. Remember that you will analyze your data according to the objectives. Remember, our objective was to look if the curve is really exponential or not. So you plot and see. So you have to analyze. You'll analyze that data by plotting a graph. Using that data you have collected at this video, you use to analyze and plot that graph. Now, what are you supposed to do? How will you analyze the data? You will have to plot a graph of the excessive temperature. You understand? To get the excessive temperature, you will say that that temperature reading, that temperature of water minus the room temperature. Remember, before you study the experiment, you will have to identify or measure the room temperature so that will enable you to calculate the excessive temperature. And this graph actually is what I plotted. And you find that there's high rate of cooling as at the beginning, but when the temperature reaches the room temperature, you find that the graph tends to be much constant. Okay.